All right, so let me get this off at some point and put this back on. All right, now we have seen that these batteries or voltaic cells can change their voltage with different metals. And we have seen that, hopefully, that batteries, all batteries, have the same kind of pieces to them. Obviously, this one's not working because what's missing? The salt bridge. Every battery must have an ability, okay, to provide movement of ions, positive and negative, in order to maintain what? Keep each beaker from getting positive or negative. Maintain electrical neutrality. Without the what? Without the salt bridge or an ability for ions to equalize themselves and maintain electrical neutrality, there's no battery. Obviously, over time, the anode disappears and the number of copper plus 2 ions disappear. Now, if I was to go to our web page, we're going to see some examples of some other batteries that may look a little different, but are in fact using the same principles. So let's go to our class web page, and I put some animations up. If you haven't been there in a while, that means you haven't done your homework. Okay, so this is a classic battery right here. Let me just make this Command plus. All right, this is what you guys see a lot, okay, in your regular day life, alkaline batteries. Now, the word alkaline means there's a base involved, okay? So let me just play this.
In an alkaline battery, zinc.
Now, just taking the thing off, what we have very simply is electrons flowing from what to what? Always from the what to what? Place of oxidation to reduction. So we're going from the what? Anode to the cathode. So what part of your alkaline battery is positive? The top or the bottom? Now that you know that, and you guess what? We knew that previously. What part of the battery is your cathode? Top, which is positive. Now, these reactions are a little different than what we're dealing with, but they're still redox reactions. Let's look at them. At the cathode, okay, or the place where electrons are flowing. Now we notice there's a couple different things. There's someone gaining electrons, okay, and there's someone losing them. So this would have to be where the reduction is occurring. Now notice the reduction is right here. Manganese oxide plus water plus 2 electrons. Okay, it's absorbing electrons, becomes this hydroxide, which is alkaline. Now, the biggest thing here is we have zinc, who is pretty active metal, pushes its electrons onto the manganese dioxide. But you notice there's a separation. Okay, and that separation is forced to flow through the wire to get to the manganese dioxide. So here's the zinc. Okay, the zinc is more in the inner core. It's forced to send its electrons to this part, which is touched to the manganese dioxide. If they did touch, what would happen? They'd flow together. And of course, you're going to watch some salt ions. So again, it's not as simple as the system you're seeing here, but it has the same principles. There's what? Electrons being given off. There's oxidation. That's occurring at the anode, which is right here. And then there's reduction, gaining electrons. And that's at the cathode, which is at this part touching that positive part. So I'll play that once more. And again, it's not about getting lost in the sauce here in terms of the specifics. But, okay, you can clearly see ions are flowing. See this ion? OH minus? The ion is flowing this way. And it's flowing through the what, you think? Salt bridge. The negative ion of the hydroxide by the reduction, okay, is flowing into the zinc to maintain electrical neutrality. The zinc becomes Okay, zinc oxide. So we have the OH minus doing so. And I'm not going to sit here and try to confuse you, but they have the same exact principles. They don't look exactly the same as our simplistic batteries, but I want you to understand all batteries work by very simple principles. Okay, getting away from that. Now, what about something even simpler? Okay, what if you were stuck on an island and you crashed your boat and you had the metals from your boat and you had the radio and you had some wires, but you didn't have any fancy chemicals, no elaborate design of an alkaline battery, no voltmeter and beautiful pieces of wires and so forth and so on. You don't have anything. Could you make a battery? And the answer is yes. Okay? So here's a potato, or potato. Now, in the potato, there's water and there's ions. And there's also cell membranes. Cell membranes, what? Separate one cell from another, correct? And you learned in biology that ions can flow through certain channels of cell membranes. Hey, these guys have salt bridges built into them. So I don't have to have a sexy setup to make a battery. I don't. So let's get rid of this setup, okay? It might look pretty, but it's not necessary. So let's get rid of this. Let's add our potato, okay? All right, and we have no voltage. Let's pick some metals. All right, and I had some metals out. At least I thought I did. All right, here. No? Yeah, one's right there. Okay, so take some metals. All right, I don't know. Let's pick, let's see here, what do I have? Iron, Fe. Stick that baby right in there. Okay, and how about some brass? Brass could be a knob made of copper and zinc. It's an alloy. All right. Not very, again, sexy, but what can I do is, wait a minute, who's better, you think, copper or iron? Even though we might be in the, wild, we have to remember our series. Now, if you don't like this potential table, let's go down to the next one. Who is higher, iron or copper? Fe. So Fe is going to tell me that that's my what? Anode. Anoid. I'm getting annoyed. Okay? And then the copper in the brass will be my what? And I've got a battery.
Wait, why do you barely put it on?
I could aggressively put it on if you like.
Yeah.
Okay? So, I don't want to pull it off. So there's a battery. And if I took my potatoes and put them in series, I could maybe run a radio. Okay, or a transmitter. Or maybe my mobile phone. Who knows? Do they say mobile phones anymore? I'm getting old. Okay, all phones are mobile, aren't they? I mean, who has a landline? I ran out the house and I ran out of line. Okay. All right, any case, now could I change the strength of this battery? What if I used a more reactive metal than iron as my anode? Let's use aluminum, as we say in New England. Okay, so go find some aluminum. Okay, change my anode out. What's acting as my salt bridge in here? The potato has ions that are flowing from one cells to the other. Now, I'm going to switch out this to aluminum. Okay, just put him in there. Again, doesn't look pretty, not very scientific, but here we go. Now, aluminum is better at what? Oxidizing or reducing than the iron I had here. Oxidizing is better at pushing the charge, so here's with aluminum. And now my battery has a higher voltage. That makes sense. Everything we learned. Everything we learned. But wait a minute. This to me is too fancy of a setup in general. I think this is way too fancy. Do the metals have to be cut rectangles to work? I mean, let's be honest. Does it have to be this nice? So let's, Christmas. Okay, let's keep that there so we can see it. All right, everyone read that? All right, now, so here's my battery. But this seems too nice, because on a shipwreck you're not going to say, hey, where's my rectangled electrodes of different metals? Okay? You're going to have a potato, because no one cooked it, no one ate it. Okay? At least not yet. All right? But, so what am I left with? Got a battery. And the question is, I don't know which one is the anode. I'm going to assume that this is made of aluminum or iron, or the switch. You're right, if I'm not sure. So, okay, I got negative volts, right? So I know that I probably got to switch these. Because we don't know what they're made of, because there's no markings on them. So, that ain't very powerful, is it? No, so let's change out one of these metals. The key is not really doing it justice. Let's do, I don't know, it's just sitting in front of me. A pole stand. Okay, so we got a pole stand in my potato. Okay, and let's assume that this is the, I'm not sure, this is the, probably made of iron. What do I got? Hey, I got a battery for a second. 0.66. Oh! I got a battery. Not very marketable. It's not a rust here, that's why. Okay. What other objects could I use? I don't know. This one needs to have, they have the door stoppers on these. There should be one that's broken. Oh yeah, give me one of those. Hey, we're a shipwreck. You don't know what you have, right? The question is how you get this in here. Ow. I need some help here, though. Hold on, let's get this in first. Oh yeah. There we go. We're making ourselves a battery here. Okay. Now, if these are the same metals, we're in trouble, but I don't think they are. Okay, so let's find our anode. All right. I'm going to assume it's going to be this guy, and then my cathode. Christmas in July. You see now? That didn't work. I turned it off. All right, so you good? Yep. Okay, so I got I don't think I'm in here good. Oh yeah, that's nasty. Hold on. My battery's breaking up. Horrible.
That's negative.
So I got it opposite. Dagnabbit, tricks up for kids. All right, so that one's there. And then that one's here. Come on, give me some. I want to be alive! Hold on. Zoom this baby in. Okay, you ready? So I got, it has to be sitting some. It's alive! I got a battery! Oh. Not much I can do with this, but I got a battery. Okay, now if I had braces, I'd work those out too. So you usually just jam the potato in your braces. Do one metal.
Sarah had to answer that.
Let's go, Sarah.
Do it. Sarah, do it.
Just kidding. We're not going to jam this in her mouth.
You
Okay.
Get up.
She was like, huh? Gallagher constant. We got that guy? Okay. What else can we use? Oh, we go. Need a metal. Back to the keys, I think. Oh, yeah. That thing's bleeding. All right, look. Okay, I don't know which one's the anode or the cathode, I'm guessing. So I don't know what the metals are. This is probably iron, that's probably aluminum. Okay. Oh, it's really negative. So I got to do what? Switch, right? I got a battery! Can't really put in your pocket. But there you go. You don't need to have fancy materials to have your battery. Okay, now I'm going to smell like oranges all day. All right? Wow, that's really gross. Eat it.
Oh. Spit it out. Spit it out. Stop. Spit it out. Be a man. You just shoved it. That was in the dirt. Don't tell him to spit it out. Oh my God.
I just ate a battery.
Ew. That is so gross.
I got the power! Sorry, had to do it. All right, that's good enough. I may not post this.